So this is video number 2. As discussed earlier, I just try to explain how talar fractures are different from any other fracture, and I'm hoping that this video can kind of explain some of those things. So as with all fractures, if you break your wrist, they'll determine if it's the bones are in alignment, and then if they are, they'll put you in a cast. And then in 2 weeks, your body starts to form a callus, and it starts to, sort of reabsorb the matrix of minerals. And then as the blood flow increases to that area, it sort of deposits new matrices, and it causes the bones to heal. So within 2 weeks, you're starting to show some healing, and then by the, like usually 4 to 6 weeks, you've got pretty significant bone healing. And then and that's true of the ankle as well. It's true of if you break this fibula or if you break the tibia, they'll usually place you in a, for example, a non-weight-bearing cast, or if it's separated, or if it's a funny odd break, they'll have to do surgery to put it back into alignment, and then put a plate and screws, and then allow for you to be non-weight-bearing. So it gives your body the opportunity to heal it and strengthen the bone, because the hardware generally doesn't do very much to actually support you. I mean, I know that it sounds like it does because there's plates and screws, but that's actually not the case. Your bone is far more superior to any hardware. So let me explain specifically in my case scenario. When I broke my ankle, I had my went in for my 1-week follow-up after my surgery to put in hardware, my 5 screws, 3 into the talus, 2 into the tibia. I also broke the medial malleolus, this part, the inner area, the inner bump right here. And this is the outer bump, the fibula. So anyways, as you can see, here's my great toe, my smaller toes, my pinky toe. My foot is just kind of, it's turning this way. And the reason why it's turning this way is because when they put this these screws into this the tibia, it just shifted over, and the joint spacing got wider on this end, and therefore my ankle gradually wanted to be rolled outward, kind of at its normal neutral state. All right, so as I was saying, with talar fractures, they also can occur, for example, with like skiers or snowboarders, because your ankle is secured, and doesn't allow for it to roll in or outward, and that's actually kind of the beauty of your body, is that when you're spraining your ankle, you'll likely break one of these bones or one of these bones if it's a really significant sprain. I mean, a sprain is a tear of the ligaments that attach usually between like the bones, meaning if you really extend the range of motion, you might tear a ligament or partially tear something, and they'll do an MRI and confirm it. And then sometimes it warrants having surgery. Most times it does not, because your body can scar and heal. As far as the bone goes, if it's a really significant sprain, sometimes it ruptures the ligaments, but it also breaks your for example, the fibula or the tibia, the medial or the lateral malleolus. But in the case of a talar fracture, the reason why it's so unique is because most times, people are usually spraining an ankle that causes a fracture. There's movement lateral or rolling of inward or outward. With a talar fracture, it's usually if you fall off of a roof, you land directly on your foot. Well, all the pressure is not really in these bones right here, but it goes primarily, it affects the talus, and that's generally kind of the mechanism of how the talus gets fractured. I will show you some pictures. So this is, I'm trying to think, this is probably like 3 to 6 weeks after my surgery. I'm going to zoom in a little bit. So let me show you. So right away after my surgery, this is what, see how this, very like dense white, especially densely white on the outside, that just kind of shows you the strength of a bone. There's a lot of white densities, which is normal for a bone on an x-ray. when you have surgery and you're advised to not walk on your foot, well then what happens is bone resorption. You have all these minerals and matrices of calcium and other minerals that are being pulled back into your blood supply to kind of, because it needs to sort of digest those things in order to start new bone formation. It can't just add, it must take away and then add. So that's why you have this, see how it's so light? It's almost like a ghost, and the fibula is a ghost, and the tibia is a ghost. But then you have this talus right here that looks so strong. But that's actually deceiving because, when you break your talus, it's completely covered in cartilage. There's only one area where it has blood supply, and when I split it in half, my talus was getting no blood supply. This white density right here, this is like old bone matrix that's not getting any new bone, because bone is only strong as it's actively being replaced with new matrices. This is white, dense. This is my surgeon was telling me that this is kind of a bad sign, and it's an indication of avascular necrosis. Two most common complications of any talar fracture is you almost always have arthritis because of just the nature of the fracture. But worse than that is avascular necrosis. When you don't have a blood supply, you have old bone that doesn't have any strength in itself. It deteriorates, and if you walk on that white, dense bone that's not good bone, it's not new bone, it will compress and it will collapse. And then you have no talus to work with, and then they usually have to do some other forms of treatment or further non-weight bearing. So obviously this was really bad news because I have to wait a long time. And in my case, I had to wait 5.5 months before I could start, actually before I took my first step in a cam walker boot, which is like a Velcro boot. So yeah, so this is, we were kind of hoping, every month I had a follow-up. I believe it was every month I had a follow-up, and then we kind of reevaluated the new x-rays to see whether this begins to go lighter or more ghost-like, because that would indicate that you have more bone resorption and therefore a bone that's healing. Just looking through these x-rays, as you can see, there's the talus. Let me find you a better picture. So as you can see, when they did that surgery to put it together, it's not in perfect alignment. The bone is kind of here and it's kind of there. I think I had a picture where you can kind of see that, kind of what it looks like when they put screws in, because it's not perfect, Dang it. Okay, I think this is a good picture. Because even though they placed the screws, I had two for, I'm trying to remember. I think I had two from the back, one from the front, I'm not really sure. One from the side. Anyways, even after they put these, the talus back together, you can see it's missing all kinds of pieces here. There's a very definite crack, meaning the bone isn't even close to filling in. And then, not quite in perfect alignment, but it was something. But you can see joint spacing, which is good, and relative joint spacing, which is good. All right, I guess I'll make another video.